Okay guys, welcome to my YouTube channel. Today we'll be talking about the exploration of computer components, a visual journey. In this video, we will be exploring the various components of a computer system, understanding the key technical specifications, how the component interacts, and any recent advancements or developments in the component. Now, here are some key technical specifications of a motherboard. The first one being a form factor. It is the size and shape and physical configuration of the motherboard. It determines additional parameters like casing, power supply, mounting holes, and overall physical layout. The second one is CPU socket. It is the slot on the motherboard where the CPU is installed. The socket type determines the type of CPU that can be used with the motherboard, and it is designed with thousands of pins or contact points for power and data transfer between CPU and the rest of the processors on the motherboard. Third one being chipset. It is the spine of the PC to which everything is connected. It is a group of chips on the motherboard that controls communication between the CPU, RAM, and other components. The chipset also determines what features the motherboard has, such as USB ports, SATA ports, and PCI Express slots. Fourth one being RAM or DIMM slots, or dual inline module slot. These are slots on the motherboard where the RAM modules are installed. The number of slots and type of RAM supported by a motherboard varies depending on the chipset and form factor. The number of RAM slots is usually between 1 and 8 depending on the manufacturer's specifications. The fifth one being USB ports. These are the ports on the motherboard that allow USB devices to be connected to the computer. The number and type of USB ports vary depending on the chipset and form factor. These allow USB ports outside a computer casing to be connected to the motherboard with an internal cable. Video connectors. These are the ports on the motherboard that allow a monitor to be connected to the computer. The most common video connectors are HDMI, DisplayPort, VGA, and DVI-D. Digital Visual Interference, or DVI, is a common video connector for display devices. It supports the transmission of high-resolution video data. PCIe slots. These are the slots on a motherboard that allow expansion cards such as graphics cards, sound cards, and network cards to be installed. They are an interface standard for connecting high-speed input-output HSIO components. The number and type of PCIe slots vary depending on the chipset and form factor. Powerful computers have a number of these, as one can add GPUs, RAID cards, Wi-Fi cards, or SSD solid-state drive add-on cards. SATA ports. These are the ports on the motherboard that allow SATA devices such as hard drives and solid-state drives to be connected to the computer. The number of SATA ports varies depending on the chipset and form factor. Serial Advanced Technology Attachment, also known as Serial ATA or SATA, enables mass storage devices such as hard drives and optical drives to communicate with the motherboard using high-speed serial cable over 2 pairs of conductors. The next one is inbuilt Wi-Fi. Some motherboards have inbuilt Wi-Fi capabilities that allow them to connect to wireless networks without requiring an additional Wi-Fi card. RGB headers. These are headers on the motherboard that allow RGB lighting strips to be connected to it for aesthetic purposes. Now, How does the motherboard interact with computer components? The motherboard provides and distributes power optimally. The computer requires electricity to function. The motherboard has a power connector plug that connects the computer to a power source and converts it into a form of electrical power that the computer can use. In addition to providing lines of communication between different add-in components like the best RAM, the motherboard also houses essential circuits, chips, sockets, slots, and ports that determine the performance, expandability, and compatibility of your computer system, as well as regulating the power from your power supply unit to everything else in the PC to make sure everything operates safely. The motherboard is the backbone that ties the computer's components together at one spot and allows them to talk to each other. Without it, none of the computer pieces such as the CPU, GPU, or hard drive could interact. Total motherboard functionality is necessary for a computer to work well. Now here are the developments and advancements in motherboard. Now, with the form factor, designed as an evolution to the previous AT form factor. Now there is an ATX, or Advanced Technology Extended form factor, which marks a profound change in the architecture of a motherboard and other components such as the cabinet and the power supply. Within the motherboard, there are significant changes as the location of the CPU, such as the location of the CPU socket, which is now placed near the power supply, thus allowing the flow of air caused by the fan of the source and not to be interfered with by an element as it happened with the previous one being the AT. The second component to be covered is the CPU. CPU, or Central Processing Unit, is the brain of the computer. Like a human brain, the CPU controls all the functions of the computer. The CPU's job is to listen for input data from devices like a mouse or other software. Then it looks up instructions for that data and executes those instructions. Here are the key technical specifications for a CPU. First one being clock speed. It is the speed at which the CPU can execute instructions. It is measured in gigahertz and determines how fast the CPU can perform tasks. Second one being number of cores. It is the number of processing units inside the CPU. A higher number of cores means that the CPU can perform more tasks simultaneously. Third one is cache. It is a small amount of memory inside the CPU that stores frequently used data. A larger cache can improve the performance of the CPU. Thermal design power, TDP, is the maximum amount of heat that a CPU generates when running at full speed. It is measured in watts and determines how much cooling a CPU requires. Integrated graphics. Some CPUs have integrated graphics, which means that they have graphics processing unit built into them. Integrated graphics are less powerful than dedicated GPUs, but are sufficient for basic tasks such as browsing and office work. Now, the next one is socket type. It is the physical interface between the CPU and the motherboard. The socket type determines what CPUs are compatible with a particular motherboard. Last one being hyperthreading. It is a technology that allows a single core to execute multiple threads simultaneously. This can improve the performance of CPUs that have a low number of cores. Now, how does the CPU interact with the computer system? The CPU communicates with other computer components such as the memory through the system bus, which is like a highway that allows the different components of a computer to communicate with each other. As for peripherals, the devices connected to the processor use a type of bus called peripheral component interconnect, commonly referred to as PCI. So it communicates with components like the mouse, keyboard, through the motherboard. The CPU interacts with computer components through a system called bus. A bus is a communication system that connects all the internal components of a computer together. It's like a central nervous system of the computer. There are several types of buses, including the system bus, memory bus, and the I/O bus. The CPU is connected to the system bus, which in turn is connected to the memory and I/O buses. Data flows back and forth between the CPU and other components through these buses. The CPU uses signals on the bus to send commands to other components and receives data from them in return. Now, there have been significant advancements in CPU technology. The first one being the exponential increase in power. This basically means that engineers are able to cram more and more of the building blocks or transistors into the same amount of space as time goes on. More transistors mean more units available to execute instructions, which equates to a faster processor with more features. Second one is improved clock speed. Another factor which greatly affects how quickly a processor can decode that HD video stream or brute force crack your neighbor's Wi-Fi password is clock speed. Early processors had a clock speed of just a few kilohertz, while most modern processors operate at gigahertz speeds. Processor speed has historically been measured in the terms of instructions per second. New processors are so fast that they can be measured in orders of millions and billions of instructions per second. The following graphics show how mainstream processor speed have climbed over the decades. Third one is the move from single-core CPUs to multi-core CPUs. This has increased performance as multi-core processors can improve the performance of applications that are designed to run in parallel. This can result in faster processing times and better overall system performance. Fourth one is the introduction of a new instruction sets such as SSE or streaming, SIMD, single instruction multiple data extensions, and AVX, which is advanced vector extensions. Fifth one is the instruction of integrated GPUs or graphic processing units on the CPU die. The sixth one is the move from CPU based on silicon to CPUs based on alternative materials such as gallium nitride. These advancements have allowed CPUs to become more powerful, more efficient, and more compact. The third component is computer memory, which is a device that is used to store data or programs or sequences of instructions on a temporary or permanent basis for use in an electronic digital computer. There are two main types of computer memory. RAM, which is random access memory, is a form of semiconductor memory technology that is used for reading and writing data in any order. It is used for such applications as the computer or processor memory, where variables and other stored and read many times to and from this type of memory. ROM or read-only memory is a form of semiconductor memory technology used where the data is written once and then not changed. In view of this, it is used where data needs to be stored permanently, even when the power is removed. Many memory technologies lose the data once the power is removed. Here are the key technical specifications in RAM. Capacity, measured in gigabytes. The higher the capacity, the more data can be stored by applications. At higher capacities, more applications can run simultaneously and programs can store larger amounts of temporary data. Speed, measured in mega transfers per second, or MTS. This is often also treated as the speed in megahertz, although it is a different measurement than clock speed. Higher speed ratings mean a faster response to read and write requests, and therefore improved performance. Next one is bandwidth, which is measured in gigabytes per second. Next one is erase time, the time it takes to erase data from ROM, which is usually measured in milliseconds. Next one is write endurance, the number of times the read-only memory can be written before it fails, usually measured in cycles. Next one is latency, the time it takes to access a particular location in storage. The relevant unit of measurement is typically nanosecond for primary storage, millisecond for secondary storage, and second for tertiary storage. It may make sense to separate read latency and write latency, especially for non-volatile memory and in case of sequential access storage, minimum, maximum, and average latency. Next one is throughput, the rate at which information can be read from or written to the storage. In computer data storage, throughput is usually expressed in terms of megabytes per second, MB per S, through bit rate, although bit rate may also be used. As with latency, read rate and write rate may need to be differentiated. Also, accessing media sequentially as opposed to randomly typically yields maximum throughput. Next one is granularity, which is the size of the largest chunk of data that can be efficiently accessed as a single unit, for example, without introducing additional latency. Last one is reliability, the probability of spontaneous bit value change under various conditions or overall failure rate. Now, how does computer memory interact with computer components? Computer memory interacts with other computer components in a few different ways. First, the CPU can access data stored in the memory directly. Second, the memory can be accessed by other components such as the graphics card or hard drive via the memory controller. Finally, the memory can be accessed by external devices such as USB drives or the internet via the motherboard's memory interface. All these interactions allow the computer to access and use data stored in the memory. Now, there are several advancements in computer memory over the years. One of the most significant was the development of DRAM, or dynamic random access memory, which allowed for much higher capacity than previous memory technologies. Another key advancement was the development of NAND flash memory, which is used in most modern solid-state drives, SSDs. NAND flash memory is much faster and more durable than traditional hard drives, and it has become the standard for storage in many devices. More recently, 3D X-point memory has been developed, which offers even higher performance than NAND flash memory. The fourth component is storage. Here are the key technical specifications. The main technical specification for computer storage is capacity. Capacity is the amount of data the storage device can hold, measured in gigabytes, terabytes, or petabytes. Next one is read or write speed, which is the speed at which the data can be read from or written to the storage device. It is measured in megabytes per second, gigabytes per second, or terabytes per second. Last one is access time, which is the time it takes to access a specific piece of data stored on the device. It is measured in milliseconds, or ms. Now, how does storage interact with computer components? Well, the primary way that storage interacts with other computer components is through the storage controller. The storage controller is a chip that manages the transfer of data to and from the storage device. It receives requests for data from the CPU, memory, or other components, and it communicates with the storage device to fulfill those requests. The storage controller also performs tasks like error checking and data compression, which help to improve the performance and reliability of the storage system. Finally, the storage controller interfaces with the operating system, which helps to manage the storage device. Here are the recent advancements in computer storage. First one being cloud storage, which offers many advantages for innovation and collaboration, including scalability, flexibility, cost effectiveness, accessibility, and security. With cloud computing, one can access more or less resources as needed without investing in hardware or software upfront. The next one being one of the most notable developments in computer storage, which is solid state drives, which use flash memory instead of spinning disks. SSDs have significantly faster read or write speeds than traditional hard drives, and they also consume less power and generate less heat. Another recent advancement is the introduction of non-volatile memory express, or NVMe, which is a new interface for accessing SSDs. NVMe allows for even faster read or write speeds and lower latency than previous interfaces. The fifth component is graphics. Here are the key technical specifications for graphic interface. The three main technical specifications are resolution, frame rate, and refresh rate. Resolution refers to the number of pixels on the screen and is typically measured in megapixels. Higher resolution images look sharper and more detailed. Second one, frame rate, which is the number of frames per second, or FPS, that the graphics system can display. A higher frame rate makes animations and movement appear smoother. Refresh rate is the number of times per second the screen is refreshed. A higher refresh rate can reduce eye strain and make the image appear smoother. Now, how do graphics interact with computer components? Graphics interact with several other computer components to create a complete graphics system. The graphics card is the most important component, and it is responsible for processing the graphics data and outputting it to the display. The graphics card connects to the motherboard, which provides the power and data connections for the card. The display, such as a monitor or TV, receives the graphics output from the graphics card and displays it. Finally, the operating system and graphics drivers provide the software layer that allows the graphics card to communicate with the other components. There have been some recent advancements in graphics technology. First one being artificial intelligence, AI, which is becoming an increasingly popular technology in the graphics design industry. AI-powered tools can automate tasks such as image recognition, color selection, and font pairing, saving designers time and improving efficiency. Yes, there have been several advancements in other graphic software in recent years. Another one is ray tracing, which is rendering technique that provides more realistic lighting and shadows. Finally, virtual reality. VR and augmented reality AR have seen significant improvements in recent years with more realistic and immersive experiences. The sixth component is sound. Technical specifications. There are a few main technical specifications for sound technology. The first is bit depth, which is the number of bits used to represent the sound data. A higher bit depth results in better sound quality. The second is sample rate, which is the number of samples per second used to represent the sound. A higher sample rate allows for a higher frequency range and better sound quality. Thirdly, there's the format used to store the sound data. Common formats include WAV, which is the waveform audio file format, FLAC or FLAC, which is the free lossless audio codec, and MP3. Lastly, it is also important to consider the number of channels supported by the sound card. Many sound cards support 2 channels, 4 channel, or even 8 channel radio. There are also other features to consider, such as digital to analog converters, DACs, and noise reduction technology. Now, how do sound components interact with the computer? Like a graphics card, a sound card uses software to help it communicate with applications and with the rest of the computer. The software includes the card's drivers, which allow the card to communicate with the operating system. The sound card interacts with several other computer components in order to play sound. First, the sound card needs to receive data from the operating system. The operating system uses a device driver to communicate with the sound card. Once the sound card receives the data, it converts the digital audio data to an analog signal using DACs. The analog signal is then sent to the speaker or headphones to be heard. Some sound cards also have features like DSP or digital signal processing chips, which allow for additional effects like surround sound or equalization. Now, there have been some advancements in sound technology. First one is focus sound, which is another type of technology that has improved the sound system. With focus sound, multiple drivers are used with calculated delays, concentrating the audio into a sound column. This type of technology is especially useful when you need to add audio to a museum display, for instance. The second one is wireless headphone technology. Manufacturers made the realization that a microphone would be more efficient if it behaved more like a cell phone. In this new system, a microphone is paired with a receiver, similar to a Bluetooth device. Once paired, the microphone is steadily monitored for the best available channel in that frequency. This process fully occurs without the user's awareness. No static, no dropouts, no hassle. Furthermore, newer wireless microphones offer security that was not available before, which is encryption. Also, there are wireless headphones which have improved listening as there are no wires involved. So this improves flexibility and durability. The final component is power supply unit. These are the key technical specifications for computer power supply. Input voltage. It is the magnitude and type of voltage in volts applied to the power supply. This can be an AC or DC voltage. Output current. It is the current in amps associated with the output voltage, typically given as a range or as a minimum and maximum values. If the power supply produces more than one voltage or multiple channel power supply, for each output voltage there is a corresponding current that must be specified. Then there is output power. Is the power in watts delivered to the load. The rated power of the power supply must match the power requirements of the system, as an undersized device will cause power failures and computer rebooting, and is acceptable to use a power supply with an output power that exceeds the requirements of the application, as most are designed to step down the amount of power demanded from them. This chart provides suggestions for power supply wattage based on computer system size. Regulation is the next one, which indicates the stability of the output voltage. There are 2 types of regulation that can be specified when selecting a power supply. The first one being line regulation. which is the maximum steady state amount that the output voltage changes as a result of a specified change in input line voltage. Line regulation is expressed as a percentage of output voltage caused by changes in the magnitude of line or input voltage. Load regulation is the maximum steady state amount that the output voltage changes as a result of a specified change in load. Typically, load regulation is expressed as a percentage or as a percent change of output voltage caused by increasing the load from half load to full load. Operating temperature is the acceptable temperature range at which the power supply can function safely. Now, how does the computer power supply unit interact with other computer components? The power unit is responsible for providing the necessary power to all other computer components. It receives power from the wall outlet and converts it to different voltages that the different components require. The PSU is connected to the motherboard via the 24-pin power connector. The motherboard distributes the power from the PSU to other components. The PSU also has several other connectors including SATA 4-pin and 6-pin connectors. Some high-end PSUs also have modular cables which allow for easier cable management. There have been some advancements in computer power supply unit technology. One of the biggest advancements is the introduction of 80+ certification. This is a standard that measures the efficiency of the PSU. PSUs with this certification are more efficient and waste less power. Another advancement is the introduction of digital control systems. These systems allow the PSU to more accurately provide the correct amount of power to the components, resulting in a more stable system. Finally, PSUs are more available with higher wattages to support more powerful components. This allows for systems with multiple graphic cards or high-end processors. And that is the end of the presentation. Be sure to tune in to more presentations in future. Don't forget to subscribe. Thank you for watching.